you set up? Let's set up now. Okay, okay.
Audio input.
For people joining us online, just a 3 minutes or so break. Let's set up for our next speaker for the invited talk. Look at this. Ryzen, can you talk, please? Ryzen. Hello, Ryzen.
Yeah, can you hear me?
I can hear you. I can hear you.
Okay, good. I can hear you clearly.
Right. So you'll be up in 2 minutes. Can you share your screen with us?
Okay, let me do that. No, I can't share. I think you are still sharing.
You can't share?
You are still sharing, so I can't share.
Okay, okay, yeah. So let me just stop share. Well, can you share now?
Okay, let me do that.
Okay.
Yeah. You can see my screen?
Oh, absolutely. I can.
Okay. What do you see? Jupyter Lab?
Yeah, Jupyter Lab, yes.
Okay, cool. So how's Port Harcourt?
Oh yeah. Port Harcourt is how it is. I mean, it's been whatever. We've been trying to make sure that things work here.
It's nice. You guys are doing a good job. So okay, so when it's time, just signal me.
Sure, I will do that.
All right, thank you.
Right, so I believe we can start rounding up now. We can start rounding up so we can. Seconds. 30 seconds, please. So guys, we can just come back now. We can finish off this later, please. Okay. Okay. Before I'll engage Rising Odegua in the talk, I have to do a proper introduction. So yeah. So yeah. So Rising Odegua is I don't even know how to do introduction. This is really important. He's contributed so much to the Nigerian AI ecosystem that it's really hard to do this introduction personally for me. So Rising Odegua, nevertheless, is a machine learning engineer and an AI researcher. So he's of course, if you, how many of us know archives? Archives, that's like the largest scientific paper for publishing. He has the papers there already. That shows you the pedigree of researcher to this state he is. And he has also contributed so much to whether it's the data science Nigeria community or it's the AI community in general. If you are in this AI community, data science community, and you don't know Rising Odegua, then I don't think you're you're really doing so much in the space online when it comes to social media and things like that. He's also the creator of he's the author of two papers. One is Rising Please.
An ensemble, it's an ensemble technique
Okay,
paper.
if you are familiar with machine learning methods, ensemble is just about stacking different models together for you to achieve with stacking different traditional machine learning models together and using that achieving state of the art gradient boosting and all of those traditional machine learning. Then he's also the author of his recently released paper and recently released Python library for machine learning, Datasist. So Datasist is a machine learning library for data analysis as well as feature engineering. So if you've done, I think George has taken you guys, some of you guys on feature engineering, and you've seen how a pain it is to really engineer data and clean data and things like this. So Datasys has a lot of abstraction, can help you abstract all of those things for you. And he's also the lead of AI Plus AAU, that's in Benin, of course. Of course, he's a computer guy. And recently, more recently, he won the Mr. Algorithm in the data science competition. Not just the Mr. Algorithm, he won the best poster award of the Data Science Nigeria Bootcamp. You know, Data Science Nigeria Bootcamp is the gathering of the greats of the greats in data science in Nigeria. And so imagine having to top two charts in that space. So his pedigree is really unmatched in some areas when it comes to community building and giving so much to the community. So it's really my pleasure to welcome Rising Odegua, the author of Data Python Library for Feature Engineering. Rising, you have the floor.
Thank you very much, Steven. I believe everybody can hear me clearly.
Yes, yes, we can.
Oh, after that long introduction, I don't even know what to say again. But anyways, thanks, Steven. Okay, so I don't have much time. I believe, how many minutes do I have, Steven?
You have about 25 minutes, about 5 minutes for questions. So a buffer of 30 minutes.
Wow,
Sorry, a buffer of
wow,
5 minutes. So overall 30 minutes.
wow. That's really short. Okay. I actually structured this as a workshop. So, but
Okay.
25 minutes for a workshop, that would be slow, but I'm just going to try and rush it up.
All right, that's
Okay.
okay. That's no problem.
So if there's any question maybe after the class, people can always shoot me up with questions. Okay, so basically, I'm in a Jupyter Lab environment. I believe we're all data scientists there and we should know what this environment is. So this is the Jupyter Lab. If you don't know this environment, then probably you've been using the Jupyter notebooks. Okay, but I think you should migrate to Jupyter Lab because it has more features. All right, so for us to get started, I'm going to, I don't know. Oh, sorry, can you guys see my screen now?
Yes, yes, yes.
Okay, so I wanted to show you guys the, I don't know if I can click this. Sorry, okay, maybe I'll just open a new tab. Okay, okay, the GitHub repo for Datasist. All right, so this is the GitHub repo for Datasist. So Datasist is basically just a Python library for, you can see, analysis. Okay, so for you to follow along this tutorial, I created a repository for it. So just go to my GitHub repo, come over to, let's see, repository. Okay, there's this NeurIPS Meetup workshop Port Harcourt. So you can download it or you can clone it and you can follow along this tutorial. Okay, so I have all the files there. I have the notebooks, I have the data sets and everything. So you can either clone or download. Later, you can just play around with it. Okay, so I have the files here. All right, so now I'm going to open up the notebook. Okay, I believe we're all hearing me. All right, so this is a notebook. Let me zoom in a bit. Okay, this is better. All right, so the title of my workshop is Datasist, a Python library for easy data analysis, visualization, and modeling. Okay, then this is my email in case you want to shoot me up, and this is my phone number, my WhatsApp phone number. You can always reach out to me for questions. I'm always glad to help. Okay, so what is Datasist? I'm going to be very fast. Datasist makes data analysis, visualization, cleaning, preparation, and even modeling super easy for you during prototyping. Because the thing is that as data scientists, we normally work, we majorly work on Jupyter notebooks and Jupyter Lab. And what we basically do is prototyping. Okay, so for you to prototype faster, prototyping is an iterative process. So for you to prototype faster, you have to do things faster. Why? So for example, you are getting in your data, you're trying to understand it, you're trying to prepare it, you're trying to clean it. These take time because if you ask majority of data scientists, the most time consuming part of a data analysis project is data preparation. It takes about 80% of the time. Modeling is super easy, but preparing your data, getting the right features, extracting it is time consuming. So for you to do faster prototyping, how can we make prototyping faster? That was the goal of Datasist. And there's something I like to say. Datasist was actually born not because I like building tools, or it was actually born because of laziness. I like to say that a lot. And laziness in the sense that why do I keep repeating things over and over again? Why do I keep writing the same line of code over and over again to do a particular function? Why not just abstract it and call the function anytime I need it? So there's this example here. I believe you can also see this on your screen. For example, we import pandas, we read in a data set. Now, what I want to do here is to drop missing values in a particular data set. I have features in my data set that contain missing value, and there's a particular percentage. I might want to drop missing values that have like 90 or 80% missing values. Okay, so how do I do that? I can do that with pandas by doing this. First of all, calculating the percentage. I do is any dot sum, calculate the percentage, and I drop those columns that are greater than 80. This is even an efficient version of it. Some people version of this of trying to drop missing values is going to be longer than this, but this is even an efficient version. And in this efficient version, we still have how many lines of code? Over 3 lines of code, and it's looking weird. Okay, so instead of me to do this every time I want to drop missing values that have a particular percentage, why not just do this? You can see this in just one line. You say ds.import datasist.drop missing, specify a percentage, and it does that for you automatically. That's just the overview of datasist. Instead of writing long lines of code for doing things over and over again, anytime I start a project, I do the same thing, just abstract it away and call it. So we have different functions in Datasist particular to different things that you want to do. Okay, so currently Datasist design is centered around 5 modules. Just recently we added another module for NLP, and in future versions we have more and more modules for deep learning, computer vision. Okay, so but for currently we have our design is centered around 5 modules. We have structured data, feature engineering, time series, visualization, and model. And from the name, you can guess what they do. Structured data, okay, has to do with data in tabular form, in rows and columns, pandas format, and the rest CSV files. Then the feature engineering modules has anything that has to do with feature engineering. So you just find functions that have to do with feature engineering in this module. The time series has to do with anything time, date time features. How can you extract dates? Then visualization, from there you know what to do. You visualize your data. Then modeling, how do you select model? How do you compare models? That's what you have in that module. Okay, so what you're going to learn in this workshop, there's not enough time, so I'll just skim through it. Working with data, structured data module, feature engineering, easy visualization, testing, and comparing models. So the first thing, how do you install Datasys? Now, Datasys is hosted on PyPy, so you can easily pip install it just like your normal libraries. Okay, and we are currently working on Datasys, so there are some functions that are available in the current repo on GitHub. So if you want the most recent updates, you can pip install from GitHub directly, or you can just use this. Okay, if you're from Jupyter Notebook, you're about to use your think that's the exclamation mark. All right, so before we start, let's get some data and just see how we can work with Datasist. So we've got these two data sets. In the file on my GitHub repo, there's a link here, so you can click on it and download data sets and use it for this. Or since you already have this repo, you have everything here. So you can just run this notebook and everything should run out of the box. Okay, so we imported Datasist, NumPy pandas. Now, let me just make something clear here. Datasist is not here to replace pandas and it's not here to replace NumPy. It's actually here to complement them, to make things easier for you. So you can see I still import pandas, NumPy. You might still need to do some other things by yourself. If you want customization, you might still need to do these things. Datasist is just here to complement, okay? So we import the data, train data, test data. I think I got this data from Zindi. I believe one is Zindi. Zindi is like cargo, but for Africa. Okay, so the struct data module. Now, if you look at I opened the API documentation here. Why can't I click this? Oh, sorry. Okay, so this is the API documentation. You can find this link in the GitHub repo for Datasist. Now you can see this is the Datasist. Now we have this module NLP struct data times visualization. Now if I click on struct data, that's what we're talking about now. Now you can see these are all the functions available in struct data. We have cat summarizer. I believe this was added by Emeka Boris, and I know you guys know Emeka Boris. I think this is one of his functions. Okay, then you have check, train, and test. You have a describe. So you can just go through this and see all the functions that are available in the struct data module. But we're going to highlight just some important ones. Now the first one I want to highlight is a describe function. Now this is how you use Datasist. You can import it as DS. Okay, so now if I want to use the describe function, I'm going to call it from the struct data module, because struct data has to do with tabular data. Now these are our data is in CSV format, so it's a tabular data. Okay, so we use the describe function, call it from the struct data module, and pass in our data set. So you just pass in your data set like that, and what does it do? Now remember, there's a describe function in pandas. Describe function in pandas just give you like a statistical description of your data. Okay, of just numerical features in your data. But we extended this, and if I run this particular cell, I'm sorry, I have to import this. Okay, I should have done this earlier. Probably gonna take a minute or two. Okay, so the describe function, we extended it so that you can have more description. That means you can have like a high level overview, a detailed overview of your whole data set in just that one line. I mean, look at the function describe. It means you are describing your data. So by looking at it, you should be able to like know the features of your data, know if they have missing values, statistical distribution, different things just from that. I don't know. Okay. All right. So if we run this, now you can see it gives you the first 5 data points. From there, you can know, okay, this is like the head. But this is something that most data scientists do. They want to see the first 5 data points of your data sets. Okay, so we have this, and we have random 5. Sometimes the origin of your data sets might be in a particular order, and you want to see random points in data sets. Okay, so you can have the random 5 data points, and you have the last 5. You have the first 5, the last 5, and random 5. And you also have the shape of the data. For me, I can know that this is 7,160 by 14 features. You have the size. Now you have the data types. Now note, all non-numerical features are identified as object in pandas, and they will run that. Okay. So from here, you can get an overview of what type of data are available in my data sets. You can see customer ID object, claim, which is the target, in 64. Then it gives you numerical features in data sets, then the statistical description of all the numerical columns from there. So you can interpret this, what's the mean, what's the count, standard deviation, and stuff like that. Then you also have description of categorical features, like the accounts, unique values, frequency, and the rest. Then categorical features. You see all this, you get all this from just using the describe function. Okay, so you have the unique classes and categorical features. So you can see customer ID has 7,160 unique values. So probably you might want to drop this if you are modeling. Okay, then you also have geocode 1,208. Okay, then missing values, you can see it gives you a missing count, also give you a missing percent. So from here, I can see this is 0.1, just 7 missing. This is 7.1. So, okay, they are not that big. So I might want to fill these values. All right. So that is just from the describe function, you can get that. All right. So now from the result, you can have a full description of probably understand important features and data sets all in one line. Okay. So another function I would like to show you in the struct data module is the check, train, and test set. Now, sometimes if you are doing maybe a data science competition or you're trying to build a model, you have your train and you have your test set. Now, your test set does not contain the target. So you might want to check the sampling strategy. By sampling strategy, what I mean is that was the test set sampled from the training set? If it was sampled from the training set, how was it sampled? Was it random sampled or was it time based? Now, if it was random sampled, there are some feature engineering that you can do on the training set that you can also apply to the test set. Why? Because it was random sampled, meaning train and test, the distribution of train and test is similar. So I can perform operations on both train and it will also help the test set. But if it is time-based, for time-based sampled, what you do to your train, it will not help your test set. Why? Because your test set is in the future. So you might want to get an idea of how was your test set sampled from a train set. Now you can do that by using this function, check train and test set. So you pass in the two data set, train and DS, pass in an ID. An ID is just like an index value that is kind of unique to both sets. So you pass in and you pass in any feature. You can pass in any type of feature. So I just decided to pick building dimension. So if I run this, okay, gives first a brief description. Now you see this. Now you can see the blue one is a train and the yellow one is a test set. Now you can see from this look of things, we can conclude that the test set was random sampled from the training set. So meaning the person that prepared this data just random sampled the test set from it. So that means what we can do to our train set, we can do to our test set. So you can get that by doing this. Instead of writing long lines of code, you can just do that. Also, another one is display missing. Okay, display missing will just display the missing values in your data set. So from there, you can easily, pick up the one you want to drop or fill. Okay, there's also the get cat features. Sometimes you might want to get the categorical features. Maybe you want to encode or do something with them. You can use that function. If I run this, I have the categorical features in my data set. It will return it as a list. So I can use this for whatever purpose I want. There's also the get numerical features, just like you have the get categorical features. Okay. Then there's also the get unique counts. Unique counts is that what are the unique values? How many are they in my data set? You can also do that. Okay. Now there's also a function called the join train and test. Now from this, you know that it joins two data frames together. Because most of the time, if you're prototyping, like for example, we concluded from here that the test set was sampled from the train. So that means we can apply global operations to both the train and the test set. So in that case, you might want to join the train and test set together and perform a particular operation. For example, encoding, pandas encoding. So to do that, you can use the join train and test set. It returns three values or three variables, the combination of all the data, the size of the train and the size of the test in case you want to split back your train and test set later. So you can see we did it here and we also can also split them back later after transformation. So you can do that. Now you can find more functions in the API. So these are just like some of the important functions that we have in the struct data model. And I believe my time is going. So we'll go to the next one, which is feature engineering. And I really apologize that I'm very fast, because there's really no time. But this notebook, I'll share the link with you guys. It's on my GitHub repo and it's self-explanatory. You can actually just go through it. And also I wrote an article on it. So you can just go through it and you'll understand what we're trying to do here. So the feature engineering, I think, what was I trying to do? Oh, sorry, I was trying to define feature engineering, but we can neglect that. But basically, feature engineering is just like, how would I put it, manually getting insights from the data, manually extracting important features, manipulating your data, something like that. Okay, so the functions available here, we always return a new data frame. Okay, anytime you call the feature engineering module, you will always return a new and transformed data frame. All right, so first one here is job missing. We saw this earlier. So job missing, we take a particular percentage. By default, it is 90%. So if you take a particular percentage, so for example, I might want to drop this column. There's this column that have 7.1% missing. Now, just for demo, normally I'm not supposed to drop this column. It's missing percentage is too low. I might decide to fill. But just for demo reasons, I'm just going to drop this with 7.1% missing. Okay, so I can come here and specify the percentage. Percent. Let me say 7.1. Okay, now I run this. Sorry. What's happening? Oh, sorry. I know you guys are probably screaming. That's not the place. That's not the place. All right, so display missing. Okay, 7.1. Okay, I want to drop that. So I come here. Oh, I did it already. Okay. So you see, I specify 7.1 just for demo reasons. Okay. So if I run this and I print my display missing again, I see that building. Okay, data of occupancy. Data of occupancy is gone from here. It has automatically dropped it. All right, okay. So the next function is drop redundant. Drop redundant, what are redundant features? Redundant features are simply features that contain the same values throughout. So for example, you might have maybe like a country code and you have ng throughout your data set, ng in all the points. That feature is redundant, it does not help you. Or for example, you might have missing values and ng in a data frame, in a feature. So missing values does not help, is redundant. Okay, so I did a demo here, and there's this data frame. I created an artificial data set. So you have one throughout in A. This feature is redundant. So you can easily drop those features by just passing your data set. So automatically Datasist will look for all the features that are redundant and drop them for you. So if I do this, see, it drops all the features. So if it is more than one, to drop all those features that are redundant. Okay. Then there's also the convert data type function. Now, sometimes when you have a data set, for example, look at this sample, we have date of birth, age, and name. Okay. If I look at the data types, now you see name is object, correct, in pandas. Age is represented as object, whereas age is supposed to be integer. Date of birth is represented as object, whereas it's supposed to be pandas date time. You follow? So you might have a large data set that have this problem whereby a particular feature is not correctly represented in its data type format. Okay. So what can you do? You can just call the convert data type function in the feature engineering module, just pass in your data set. It automatically goes through all the features and converts anyone that is not in the right data format. Okay. So by running this, now you see age has been converted to integer and date of birth has been converted to date time automatically. Okay. So the next one is field missing. Now sometimes you might want to do some visualization or do some probably more feature engineering, and some of your features contain missing values. Now you can easily fill missing categorical features by just passing in your whole data set. It automatically uses the mode, the frequency for categorical features to fill. Okay. So if I display missing values. Now, building dimension, I think that's a numerical feature. Date of occupancy is also a numerical. I think geocode, yeah. Geocode and guarding, I think they are categorical features. So if I run this field missing categorical and display them again, you see guarding has been filled automatically. Geocode has been filled automatically. So I'm left with the numerical features. Now, since we have field missing cards, we also have field missing so automatically it fills this. Oh, sorry, I think I passed in a new data set. Yeah, I call it DF here. So I'm supposed to pass it here. Let me do that. All right. Oh, interesting. Okay. But you get what I'm trying to say. I'm not going to try live coding now because I don't know, this thing might just. But what I'm trying to say is that the field missing will look for all the numerical features in the data set and automatically fills them for you. Okay, there's also the log transform. Sometimes some features are skewed. They might be right skewed or left skewed. And a way this can sometimes impact, not all the time, but sometimes impact your machine learning model. So it is better if you can like normalize your data set. So how do you normalize it? You can log transform. Okay. So now, first of all, let's see this building dimension. How did I know it was skewed. How did I know this video dimension was skewed? I did a plot earlier, so I'm just going to quickly, I don't know if I have, did I import SIBO? Okay, I'm just going to attempt to live code something. If it doesn't work, don't blame me. Okay, so SNS dot, I think, no, there's dist. What are you doing? There's dist plot. Yeah, I want to see the distribution. Now from train the F, I'm going to plot building dimension. Okay, what happened? Oh, building dimension contains missing values. So sorry, I'm going to quickly fill it. Missing. Okay, so I quickly filled it. Now you can see this is right skewed in the sense that everything is over to the left side, so it is right skewed. And this feature might be important for our model, so we might want to log transform it. How do we do that? We can call the log transform from our feature engineering module. So if I run this, there's a feature engineering dot log transform, pass in the columns I want to transform. If you don't pass in the column, it automatically take all the numerical columns and try to log transform them. So you can pass in a list of columns of features that you want to transform. So if I run this, it's going to, oh, I actually filled it here. Sorry. Okay, so you can see it's automatically log transform. Now you can see this is a more centered data. It is more centered than this. And I think this might be better for your model. Not all the time, but sometimes it do helps if you log transform your features. Okay, now sometimes you might also want to work with latitude and longitude. I know most data set contains latitude and longitude. Datasist has functions in the feature engineering module, like for working with data, for working with latitudes, longitudes, things that you can do. But because of time, I'm not going to cover it. So you can see we have bearing, we have, I think, yeah, the Manhattan distance and stuff like that. So they are out there. So let's quickly go to another one. Time-based features. These are very important because most data set comes with date-time features, and you might want to extract information. You can't use date-time features like that. You can't pass them to a model. You can't encode them. They're not categorical features. They are date-time features. So you might want to extract information from them, then drop them. Okay, so the first data set we're using does not contain any date time features. So I'm going to import this other data set. I also got it from Zindi. So the data set contains, you can see, is a logistic data set and contains lots of date time features. So you see placement time, confirmation time, about pickup time. If we were to do this manually, you are going to do a lot of feature engineering. You're going to be writing codes over and over and over again just to drop, maybe for example, to extract information from placement time. You're going to write a particular function. This you're doing it over and over again. So, but you can easily do this with Datasist. So how do you do that? Now, for example, I want to just give an example using placement time and arrival destination time. So these are the columns I want to extract features from. So you can call ds.timeseries.extract date. Extract date will extract the day. You can extract the day of the month, the day of the year, the month of the year, the hour, the minutes. You can extract everything just in one line. So if I run this, okay, it takes some time because it's date time. Come on. Okay, now you can see. Now we did that for placement time and arrival destination time. So two features. So it's going to create columns with the names and the specific feature it extracted. So you can see placement time. This DOW means day of the week. So you can see Friday. DOY, day of the year, day of the month, hour, minute, weekend, year, quarter, month. It's also going to do the same thing for arrival destination time. It starts everything automatically. So if you add more features to the space, it's going to do them automatically for each one of them. Now, sometimes you might not need all these features, maybe day of the week, so you can specify the ones you want by using there's a parameter called subset. So you can just pass in as a column, day of the year and the rest as list, sorry. Okay, so you can also, the documentation is also there. can use your shift tab to get this. And you can see subsets, the lists and arrays. So look at the features that you can pass in DOW, DOY, DOM, and the rest. So you can actually specify what you want to extract. Okay, so that's for that. So it's very easy to do that. Now also you can okay, that's what I explained earlier. Numerical columns. Now there's also another important function called the time plot. Now time plot helps you visualize time features so you can identify seasonalities, cardinality, no, not cardinality, seasonalities and trends in a time feature. So for example, if I have these numerical columns, I have time for pickup to arrival, destination longitude, pickup longitude, platform type, temperature. Now I want to plot them against the placement time and see if there's any trend over time. For example, does the pickup time for pickup to arrival, does it increase at a particular month, stuff like that. So I can just use this time plot, pass in the data set, pass in the numerical columns I want. If you don't pass in numerical columns, it's going to use all the numerical columns. Okay? Pass in numerical columns and pass in the time column I want to plot against. So if I run this, it's going to make a plot. Um, why are you taking time? Okay, so you can see it makes a plot. Now you can see this is for time for pickup to arrival. You can see this. I can't really observe any trend. Yeah, but I think I can see something smaller here. I think the temperature kinds of increase as we get to the end of the year. Anyway, but there's really no shouting trend here, but sometimes your data set you might get to see trend. So these are you can use the time series or the time plot. You can also do this pickup time. Okay, so we'll quickly rush to the next one. I know my time. I don't know, Steven, how many minutes do I have left?
I'll text it to you.
Okay, okay. All right. But are we following or am I too fast? I don't know because I've not gotten any feedback. I'm not hearing you guys, so I don't know.
Guys,
Are we following?
I'm following.
Okay,
All good, right?
okay, okay. So the next one I want to show you is easy visualization using Datasist. Now, sometimes you want to get insights from the data and you want to visualize. So, for example, I did visualization for building dimension up there using this plot. Okay, that was just for one. So if I wanted to do for all my numerical features, I might need to write a for loop. So I'll loop over the features, do a particular plot. Maybe I want to label. So those might take time, and as lazy programmers that we are, we don't have that type of time. So you can easily do that you can easily do visualization using Datasist. It's very easy. Okay, so we can visualize for categorical features. Now there are some particular visualization that you do for categorical features. There are the ones you do for numerical features. There are the ones you do for date time features. So it depends on what you want to do. Okay, for example, this box plot is mostly used for categorical features. What are box plot? Box plot simply plots a particular feature and gives you like the um, the quartile values where you have 25 percentile, median value, and it also helps to show outliers. So, for example, I want to plot all the categorical features in my data set against a particular target. Now, the target in this data set is the claim. Okay, so if I want to do that, now the categorical target must be a categorical value. If it is not a categorical value, if it's a numerical value, it will not plot. Why? Because box plot works with categorical features as this. Okay. So if I run this, it takes all my um, numerical features and plots them against these categorical values. So this is like a separation. Okay. So I have this. So the target is claim, and that they are telling you that you should build a machine learning model that can predict if somebody will claim insurance or not claim insurance. So that's why you have this 0 and 1. So 0 means no claim, 1 means the person actually claimed. So I'm sorry that I didn't explain the data set, but there was really no time. So this year of observation is a particular feature. So looking at this year of observation, do people tend to claim more or not claim more? From here, you can see that it's actually the same. The year does not affect it, affects the claim. Okay, now you can see this weird thing. Here you have insured period versus claim. Very weird. So let's neglect that. Also, this The residential area of the person does not really affect whether the person will claim or not claim. So there's really no separation. Okay, there's a slight separation here where you have building dimension. Okay, seems bigger buildings tend to have more claim than smaller buildings. Okay, there's really no time to get into all this, but you get the idea. So you can use bus plots to like plot all your numerical features against a particular target all in one line. So you can see. So you can actually do your exploration. And there's also the cat bus. Now, the cat bus is a feature used to make a side-by-side bar plot of all the categorical features against a categorical target. If bus plots the numerical features against a categorical target, cat bus plots categorical features against categorical target. So how do we do that? Okay, now let's see. Let's make a plot. Now you see customer ID has too many categories and will not be plotted. So if a particular categorical feature has lots of classes, it will not be plotted, okay, because you cannot interpret it. Okay, now you can see for building painted, building can either be painted N or V. I think from the explanation of data set N, I think N means the video was not painted and V means the video was painted. I'm not sure, but we can check that later. So you can see for class 0, it's actually the same with class 1. There is no really difference from there. Okay, there's also something interesting here. So you can see for building fenced, for class 0 and for class 1, you can see V has dual one than this. So you can actually investigate this further. Also, this number of windows, class 0 and class 1. Okay, then you also have the count plot. The count plot makes a bar plot of all categorical features. Now, sometimes you may want to know the count of the unique features in your data set, and you want it in pictorial form. So you can use the count plots to do that. So it's not going to plot customer ID and geocode because they have too many unique values. Okay, so you can see that means in this data set we have more V than N for building painted. Okay, V and N for building fence is the same. For garden is the same. Settlement is the same. For number of windows, we have more windows with I think this should be 4, 3. Oh, there's a funny feature here, dots. So you can see from you have to maybe do something with this dots. Maybe you can replace it, or you can. I think this was used to use in place of missing value. Maybe these were all missing, so they use dot in place of that. So feature engineering, you can replace that. Okay, so you can see we have more buildings with 4, 3, and 5 windows. Then we have fewer buildings with greater than 10 windows. Okay, so that's for that. So you can investigate further on that. All right. So you can even do count plots and separate by a particular feature. So you can see count plot is separated by claim. So you can do that also. Here also. Okay. Now, what about visualization for numerical features? Okay, you can do histograms like we did earlier, but remember you have to fill in your missing values first, or else switch one error. So you can do this. Histogram with plot histogram with all your numerical features in data set. So you can have something like this. So you can see within dimension this and that data for occupancy. I think this exhibit left skewed. Okay. Histogram of claim. Then you can also do what did I do? Oh, sorry. Okay, you can also do scatter plots for numerical features. Scatter plots is a okay. Sorry, this function makes a scatter plot of all numerical features against a numerical target. So, for example, let's use our building dimension and let's plot all these numerical features against it. Okay, so meaning this will be on our x-axis and these will all be on the y-axis. So you can see. Oh, sorry, the opposite. This is in the y-axis and this is on the x-axis. So you have building dimension in short periods. So scatter plot, you can use to detect correlation. Now you can see there's a correlation between building dimension and data for occupancy. I think this is somehow going, looks like an exponential curve. So you can investigate that further. Okay, you can also plot missing values. I think I've showed that before. Oh, this is a different kind of plot. Okay, it shows you heat maps. So you can see geocode, there's this small missing value here. It's very small. So if you like fancy stuff, you can actually use this kind of stuff. Okay, now let's come to the last part of it quickly. Testing and comparing machine learning models with Datasist. Now, most of the time, if you are working on a machine learning project, you might have a base model. Then you have like 4, 5, 6 models. You just want to try them and see which one is doing better. So for example, if I have like 5 models, I can pass it into a function in Datasist that can automatically compare those models. Take a data set, makes a comparison, shows you the ones that's doing the best. So you cannot take that one that's doing better and improve on it. Okay, so that's what Datasist can do for you. So instead of training each model separately, you can just quickly to that. So for us to do this, we have to frame a problem, okay? Because for us to create a model, we need to have a problem first. Okay, so to demonstrate this, we're going to use data set from Data Science Nigeria 2019 bootcamp, which was this recent or past bootcamp. Okay, so the task was to predict insurance claim. I don't know, let me see. I think I have internet connection. I can yeah, if you can see this, this is the page of the competition. It's still open, so maybe after this workshop, you guys can actually just take a look at it. Okay, so you can get data from me. Check the leaderboard. All right. So the goal or the task is to predict insurance claim if a person will claim insurance or not or no insurance from building observation. Okay, so we'll just use quick feature engineering so that we can easily just show the modeling process. Okay, so we're not going to do anything fancy. So what you do here will not give you number one on the leaderboard. So, but you can try out other things later. Okay, so I read in the data sets, train and test. Okay, variable definition is trying to define all the variables. If you are seeing this weird thing here, I'm just trying to increase the width of this particular column because if I don't put this, it's going to truncate most of this text. So that's why I did that. Okay, so you can see definition of each of the variables, customer ID, what it does, your observation. So this is our target claim. Okay, so basically in a data science project like this, what you basically do is to look for missing values, fill them, fill your categorical missing values, look for features that are skewed. There are lots of things that you can do. Okay, but we're going to do something very basic. So the first thing I'm going to do is to drop my customer ID column. Okay, then I fill my missing categorical feature. So you can see with Datasist, fill missing categorical, fill missing numerical. Do that on my test also. So everything I did here in just one line, my in just this how many lines of code now? My code is almost clean already. Okay, so I can run this cell now. You can see I have no missing values. Right. So after that, maybe I might want to encode. Encoding means taking your categorical features and converting them to numerical form. Because without that, your machine learning model cannot learn. Okay. So how do we do that? Now, for example, so I said for example, okay, now for you to properly encode, you need to know what type of encoding to use. And the type of encoding is dependent on the particular feature, like the number of classes in the feature. Because for example, if you have a feature that have 100 unique classes, you cannot use one of the encoding. Why? Because you have a large end goal or a large data set. Okay, so that's why I use this function called class count in the struct data module to look at the individual classes in all our categorical features. So you can see building has just 2. So this one can be not encoded. Building fence, the same thing, 2, not encoded. Number of windows, I think that's about, should be 10 or so. It can be not encoded also. So we can just decide to not encode all of them. Okay, so you can see unique classes in geocode is too large. So this is this is like one not encoded will not be good for this guy. So what we're going to do is we'll label encode geocode and use one not encode for the rest of them. Okay. Now there's this nice library called categorical encoders. Contains lots of encoding functions that you can use. So first of all, we drop the target. We save the target into a variable called target. We drop it. Then we use ordinary encoder, which is the same thing as label encoder for this guy. So it follows the sklearn API where you have fits and you have transform. So we'll do it for our train, do it for our test. Then we'll do one of encoding for the rest of the features. So I can run this. Okay, I've done that now. Take a look at the edge. Now you can see all our features are numeric. Now we're ready for modeling. Okay, so let's look at the shape. 7,000, 3,000. Okay. Now, the important function in this modeling module is the compare models. So it takes as argument multiple machine learning models and returns a metric, a plot of the metric that you can use to gauge which one is doing better. Okay. So for now, in this case, we're just going to compare 3 models: random forest, LGBM, and SGBoost. Okay. So first of all, we import them, split our data into train and test. Okay, now this is just like a base model, so you can see no heavy tuning. I'm just using the same estimator throughout 2020, so it might be biased. Okay, but I just want to just show you the process. All right, so I run this. I have light GBM, SGP. Now I create a list of classifiers, so you can see this is the 3 classifiers I create. Okay, so I call from the model module. I call compare model. I pass in the list of model, so you can see classifiers, model list. I pass in my train data. I pass in my Y chain. Y chain contains the target for this guy, and I pass in the scoring metric. Okay, so if I run this, now you can see I have random forest to have the lowest score, LGB to have the highest score. So I can easily use IGB. Okay. Now you can also use it to predict. Why? Because it's going to return models and score. So from this model, you can use the best one. Okay. So you can use it to predict. Also, you can also get classification reports from the prediction and the test. So I can run this and get like a detailed report, a classification model. So you can see accuracy, F1 score, precision record, correlation matrix, and everything. Then lastly, you can plot feature importance all in one line of code. Plot feature importance, passing the model, passing the features. So you can see within dimension, these are the most important features. Okay, so I know I was fast, but I believe you guys have had like a basic understanding of Datasist. So you can find the link to the repo here, API documentation, which is this guy. I don't know why I can't click. It's because of this, I'm sharing my screen, okay? But so basically that's Datasist for you. So I don't know. Questions?
Thank you so much, Ryzen, for your amazing session. Do we have anything to say?
Okay.
Do we have anything to say? Okay, I sent you a question, Ryzen.
Okay. I'm
Right,
going to
everyone
check
is
that.
saying thank you, Ryzen.
You're welcome.
Yeah. So I sent you a question. Please attend to it.
Okay. Let me see.
Is there I think it's on the chat
Okay.
bar, yeah.
Keep from in terms of data viz, how does Datasys compare with libraries like Matplotlib, and in terms of flexibility and the data set? Okay. In terms of visualization, Datasys is like I said earlier, Datasys is not like a replacement for Matplotlib. Datasys helps to like how would I put it, augment Matplotlib. Now there are lots of tuning and tweaking that you can do with Matplotlib and Seaborn, because just like the way Seaborn was built on top of Matplotlib to help abstract it. It's not like a replacement. So if you want to do your low-level stuff, you want to do your tweaking, you can still use Matplotlib. But if you want something fast, maybe doing prototyping, you can use Datasys. So that's just it.
All right, thank you so much. Any
I don't
other?
know if I answered the question.
Yeah, you did. I think you did answer the question. Lucky, you answered the question. Yes.
Okay.
Yeah, you did. You did, Ryzen. Any other
Okay,
question?
okay. Any other questions?
I don't think so. All right. If they have any other questions, they
Oh,
can reach out to you. Rising
yeah, you
Odegua,
can reach out.
yeah, Rising Odegua
Can reach out.
is also a mentor at the School of AI for Port Harcourt. So you can of course reach out to him whenever you have challenges using the library or things like that. He's always free to. At least he has free time to attend to things like this. So all right. Thank you so much, Ryzen.
Yeah.
Thank you so much for your question once again.
Welcome.
And I think
Thank you for.
I'll see you in the other room.
You said?
I said I'll see you in the other room.
Oh,
Yeah.
thank you very much,
All
guys.
right. No
Thank you
problem.
everyone for having me. I really appreciate it.